to another episode of Linear Inequality. It's your favorite science tutor, Professor Ernest. We have another example. This time we are considering three linear inequalities with two variables, x and y. We want to find the region of solution of these inequalities. The same procedure, but we have more graphs in this case. So let's get started. Of course, as usual, we always assume equality. So for the three linear inequalities, we assume equality. So we pick the first one, y minus 2x will be equal to 4. So when x is 0, when x equals 0, so automatically this becomes 0. That makes y to be equal to 4. So y will be equal to 4. When y equals 0, we have minus 2x to be equal to 4. Minus 2x will be equal to 4. So dividing through by minus 2 will give x to be equal to these two here, minus 2. So for the first case, we are going to be having x to be 0, while y is 4, and x minus 2, y is 0. This is for the first case. Now we pick the second equation. We assume equality, so 3y plus x will be equal to 6 based on our assumption. So when x equals 0, so automatically this becomes 0. 3y is equal to 6. 3y is equal to 6. So that makes y to be equal to 2. When y equals 0, here, that makes x to be equal to 6. So we have x to be equal to 6. At the end of the day, we have our coordinates x 0, y is 2, and x 6, y 0. These are second coordinates. Now we pick the third inequality and assume equality. So we have it as y to be equal to 7x minus 9. So in this case, when x equals 0, so this parameter becomes 0, that makes y to be equal to minus 9. So y is equal to minus 9. The same case holds when y equals 0. When y equals 0, it means I'm going to be getting minus 7x. When 7x crosses over to this side, is equal to minus 9. So dividing through by minus 7, this cancels. We have x to be equal to this cancels. 9 divided 7 gives us 1.3. At the end of the day, let's list our coordinates. X is 0, y is minus 9, and x is 1.3, y is 0. Right, these are the coordinates for the three equations. We have the first one, 0, 4, and minus 2, 0 for the first linear inequality. The second linear inequality gives us 0, 2, and 6, 0. While the third one gives us 0, minus 9, and 1.3, 0. So we have our 3 points. These 3 coordinates, we will use them to plot the graph. So let's look at the graph so that we can tell the region of solution where there is satisfaction, where the inequality is satisfied. So let's draw the graph. Drawing the graph, I'm going to consider x 0, x minus 2 the least, x 6 the greatest. For y, we have minus 9 the least. We have 4 to be the greatest. So minus 9 below, I will require more space. So this is our graph. This is point 0. On the x-axis, I'm going to be using two units. So I have 2, 4, 6, 8. On this side, I have minus 2, minus 4, minus 6. Above, I'm going to be using 2, 4, 6, 8. Below, minus 2, minus 4, minus 6, minus 8, minus 10. So this will go. Don't forget, this is the y-axis, while this is the x-axis. So let's begin plotting our graph. When x is 0, y is 4. When x is 0, y is 4. This is the point I mark. When x is minus 2, y is 0. Y is 0 here, x is minus 2. This is the point. So I mark. At the end of the day, I have my linear inequality graph for the first case. Then I have to go back to the question. The question says we have a less than or equal to. So that makes our inequality line to be a straight line. So this is for the first case, which we have as y minus 2x is less than or equal to 4. Now we do for the second case, when x is 0, y is 2. When x is 0, y is 2. So we mark our points. When x is 6, y is 0. When x is 6, 2, 4, 6, this is x6, y is 0 at this point. We mark our points. Inequality says greater than or equal to, so it's going to be a thick line that will cut across both points. This is a graph of 3y plus x is greater than or equal to 6. And finally, for the third graph, we have when x is equal to 0, y is minus 9. When x is equal to 0, y is minus 9, in between minus 8 and minus 10, so we have our point here, minus 9. When x is 1.3, y is 0. Somewhere here is 1, so let's take x here to be 1.3, y is 0 here, so we mark our point. At the end of the day, we have what connects less than or equal to, so we run a straight line down. We run a straight line down to cut through both points. So from the graph, we can tell the region of solution. The region of solution is where the graph meets each other. You can see the first graph, the second graph, and the third graph. So we have these points here. This line, and this line, they form a triangle. So this is the region of solution. So all I do is simply to shade this point. And that makes our arrow. So this region satisfies the three inequalities. I'm sure this example is clear and simplified. I want to say thank you for taking our time to watch this video, and also to remind us, if you are new to this channel, do well to subscribe to this channel. And to my returning subscriber, I want to say a big thank you for always showing up. See you next time. Bye for now.